Alright, hi. This is my math presentation, and this is a dog eating food. Okay, that's enough of that. Alright, so what we're doing today is a company uses two machines, A and B, to make boxes. Machine A makes 60% of the boxes, and B makes 40%. By the way, this is question from May 2011, paper 2, number 7. So 80% of the boxes made by machine A pass inspection, and 90% of the boxes made by machine B pass inspection. So we're selecting a box at random, and the first part is to find the probability that it passes inspection. So, the probability of a box passing inspection. We first know that with machine A, it produces 60% of the boxes, or 6/10 as shown here. B, on the other hand, produces 4/10, or 40%. A has a 0.8 pass rate and a 0.2 fail rate, and machine B has a 0.9 pass rate and a 0.1 fail rate. So in order to see the probability of a box passing inspection, what we're going to be doing is multiplying the percentage of boxes made by machine A times its pass rate, and adding that to the percentage made by machine B, and multiply that by its pass rate, and adding these two numbers together. So as you can see, moving on, the pass probability with A is 60%, or 6 over 10, times 8 over 10, which gives you a value of 0.48, and the pass probability with B is 4 over 10, or 40% of the boxes made, times 9 over 10, its pass rate, which gives you an answer of 0.36. So 0.48 plus 0.36 gives us an answer of 0.48, and that is the value of the probability of picking a box at random that passes inspection. So now part B says the company would like the probability that a box passes inspection to be 0.87. Find the percentage of boxes that should be made by machine B to achieve this. So as you can see here, we've set the probability, the percentage of boxes to be made by machine B as X, and therefore because A and B have to equal 1, we then make the probability or percentage of boxes made by machine A equal 1 minus X. We're going to do the same thing we did in part A, where we look at the relationship between the percentage and the pass rate for both A and B. So we're going to be multiplying 0.8 times 1 minus X and 0.9 times X and adding these values together. So that's exactly what we do here with the probability of pass A as shown there and the probability of pass B as shown there. A simplification gives this answer down to 0.1x equals 0.07. And solving for x gives you a value of 0.7 or 70%. Going back to this diagram here, what we see is that the percentage of boxes that should be made by machine B is 70%, and therefore 1 minus x, or 1 minus 0.7, gives you an answer of 0.3 and 30%. Therefore, we can conclude that B machine should make 70% and A machine should make 30%. That's it for the answer for this question. Thank you.